Hello guys, today we will be studying about the chapter Structure of an Atom. This chapter is a very important chapter of class 11 chemistry and plays an important role in your NEET exam as well. For an easy understanding, I have divided this chapter into three portions. The first portion is that of subatomic particles. What are subatomic particles? The subatomic particles include protons, neutrons, and electrons. Who discovered them? How they were discovered? Their charges, their masses, everything will be discussed in this portion. The second portion is of atomic models, where the atomic models proposed by Dalton, Thomson, Rutherford, Bohr, Schrödinger will be discussed. The drawbacks of these atomic models. The conclusion, the advantages of these atomic models will be discussed in detail. The third portion is of quantum chemistry, where we will be dealing with the orbitals, their energy levels, how electrons revolve around the nucleus, All these things and more will be discovered in this portion. Also, you will get an idea about what exactly happens in a chemical reaction. What exactly happens in a chemical reaction will be covered in this portion of quantum chemistry. So what is an atom? Atom is the smallest indivisible particle of an element. Everything is made up of atoms. The water you drink, the food you eat, your table, your chair, your pen, everything is made up of atoms. Yeah. But what constitutes an atom? The answer to this question lies within the definition of atomic structure. So atomic structure primarily consists of the protons, the neutrons, and the electrons. These are the things which lies inside the atoms. So here is a model of an atom. Inside it is a nucleus. Nucleus contains protons and neutrons. Protons then further contains quarks, whereas electrons revolve around the nucleus. Electrons revolve around the nucleus. So what are the charges on the electrons, protons, and neutrons, and what are their masses? So electrons are having a charge of -1 and a mass of 9.11 into 10 raised to power minus 28 grams. Protons are having a charge of +1 and a mass of 1.673 into 10 raised to power minus 24. Neutrons are neutral in charge and having a mass of 1.675 into 10 raised to power minus 24. Here we will notice that protons and neutrons differ in mass very slightly. Proton is 1.673, whereas neutron is 1.675. You need to remember these masses. They are very important from examination point of view. Numericals are asked where you need to put these values directly. So let's come on to first portion, which is discovery of subatomic particles. Electrons were discovered by J.J. Thomson through the experiment Cathode ray experiment, and value of charge and mass of electrons were determined through this experiment. Protons were discovered by E. Goldstein through anode ray experiment. Values of charge and mass of protons were discovered by him. Neutrons were discovered by J. Chadwick through the bombardment of beryllium with alpha particles. Charge and mass of neutrons were discovered by this experiment. So what is the experiment that led to discovery of electrons? The experiment that led to discovery of electrons is called cathode ray discharge tube experiment. In it, J.J. Thomson kept a discharge tube and attached it with the electric circuit. What is a discharge tube? A discharge tube is a special type of tube containing two electrodes. Here you can see this is one electron which is cathode, that is negatively charged electrode. This is the second electrode called anode, which is positively charged electrode. This discharge tube is also connected to a vacuum pump. What is the role of this vacuum pump? The role of this vacuum pump was to maintain a very low air pressure. Very low pressure. So a high voltage electric current was passed through this discharge tube containing a gas at a low pressure. And what was the observation? The observation was that a green glow was observed at the anode side. This green glow at anode side was because of the cathode rays. The cathode rays were given the name cathode rays because they emerged from this cathode, which is the negatively charged electrode. And since we observed a green glow at anode only, we got to know that there are some particles in the cathode rays, or the rays which are getting emitted from the cathode, which are getting attracted towards the positive charged electrode, which is the anode. So here it was the cathode, here it was the anode. There were some rays which were getting attracted towards the anode, which is the positively charged electrode. Since the anode was positively charged, J.J. Thomson concluded that the particles in this ray will be negatively charged because they were getting attracted towards the positive charge anode. There was no green fluorescent light here, but it was on anode side, which meant that the particles in the cathode rays contains negative charged particles. These negative charged particles were later given the name of electrons by J.J. Thomson. So what were the characteristics of these cathode rays? Here I am discussing some characteristics of these cathode rays and the experiments that proved that these characteristics were right. So the first characteristic is that cathode rays travel in a straight line. Here's the discharge tube, and in between it a metal cross was placed. When cathode rays were passed through the discharge tube, we saw that a shadow of the metal cross was formed just behind this metal cross. The shadow was formed just behind. It wasn't formed here. It wasn't formed anywhere else, but just behind us. If the rays were coming like this, it would have formed somewhere here. If the rays were coming like this, it would have formed somewhere here. But the shadow just behind led to the conclusion that cathode rays travel in a straight line. The second characteristic was that cathode rays contain material particles having both mass and velocity. How was this proved? This was proved with this experiment when we placed a light pedal wheel inside a discharge tube. Again, cathode rays were allowed to pass, and what result was that this light pedal wheel started to rotate. And we came to the conclusion that the cathode rays that are striking on this light pedal wheel contained some particles which are having both mass and velocity. That's why this wheel is rotated. If there were no mass and velocity in the cathode rays, no rotation would have been there of this light pedal wheel. This led to the conclusion that the rays are not simply rays, but are having some particles which were later called electrons. Now, how the charge was determined on these cathode rays? Cathode rays, how the charge was determined? How we came to know that it is positive charge or negative charge particles are there? Through this experiment, we will get to know. In this experiment, electric plates were placed perpendicular to the cathode rays. This is a positive charge plate and this is a negative charge plate. And cathode rays were passed through them. The result was that the cathode rays were deflected towards the positive plate. which led to the result that there might be negative charge in the cathode rays. So this experiment concluded, due to the deflection of cathode rays towards the positive plate of electric field, the particles inside the cathode rays were having a negative charge. The application of electric and magnetic fields deflected cathode rays as expected from negative charge particles. So the deflection was totally which was expected from negative charge particles. Hence, it was concluded that the cathode rays contain electrons. Now, what were the characteristics of cathode rays? Here's the conclusion. Number 1, they originated from cathode, which was the negatively charged electrode. Number 2 was they travel in straight line. Number 3 was very important, they carry a negative charge. Number 4 was they were deflected by electric and magnetic field. When we placed in the last experiment, when we placed a positive and negative charge electric plate and cathode rays was passed through it, we saw that they were deflected. So they consist of material particles. The cathode rays consist of electrons. Hence, it was the conclusion. So here I am giving you a brief conclusion of the entire experiment. The conclusion of the entire experiment was that a discharge tube was taken. Green fluorescent light was observed at anode. Which led to the conclusion that there were some particles inside the cathode rays that were attracted towards the anode. Particles attracted towards the positively charged electrode. Since they were attracted to the positive charged electrode, they were thought to be negatively charged themselves. Various characteristics of these were then experimented. They traveled in straight line. They carried mass and velocity. It was also determined that they carried a negative charge as well. And these negatively charged particles of cathode rays were given the name electrons. So this was all about the discovery of electrons. Now, how J.J. Thomson calculated the charge to mass ratio of electrons? This we will be discussing in the next slides. So, in the coming portion, we will be discussing about how charge to mass ratio was calculated, how the mass of electron was calculated, who discovered protons and how they were discovered, who discovered neutrons and how they were discovered. Everything will be discussed in the coming few slides after that. Okay, thank you so much.